All right, we're looking at Unit 1, Section 2. All right, so our goal here in 1.2, our goal is to simplify radical expressions by finding roots. All right, so if we can find a root, then we can somehow simplify what? Well, let's take a look. Let's see what this really means, and we'll come back at the end and find out if we're able to simplify radical expressions by finding roots. All right, so what is this really saying? What it really saying is, ultimately, your goal is to figure out, why is it, so why does the square root of 12 equal 2 square roots of 3? And that should be pretty interesting. Right, when I get my calculator out and I plug in the square root of 12, I'm going to get a number like 3.3 or 3.4 something. And if I put in 2 times the square root of 3, I'll end up with the same exact number. So if I plug these in my calculator, I'll get the same exact response back. So why does the square root of 12 equal, or why is it the same thing as 2 square roots of 3? All right, well, let's go find out. So the first thing, I'm going to teach you 2 different methods, okay? I'm going to teach you 2 methods on how to simplify radical expressions, and the finding roots aspect, that's going to be how we simplify these, right? So let's take a look at method 1. Method 1 should be fairly familiar. You're in ICA now, and in AG3 we did this already. So I know for sure you've seen it, but now it's really time to knuckle down and make sure you do it right. So here we're dealing with the prime factor method. And the prime factor method is fairly simple. It's straightforward. 1, I need to identify the index. Step 2, I'm going to factor the radicand. I'm going to factor completely. And step 3, we're going to take groups of factors that are the same size, so they're going to be index sized. And step 4, I need to determine what's going to be on the outside of the radicand and what's going to be on the inside of the radicand. All right, so let's take that example. All right, so here's my method. Identify the index, factor completely, group the factors together in the index size. So we'll explain that a little bit more here in just a second. And then step 3, determine what's going to be on the outside and what's going to be left on the inside. And we're going to do that through a series of examples, okay? All right, so the first example, let's take a look at the square root of 12. So if I start with the square root of 12, I know that my index is a 2. Again, there's no number out here on the front porch. There's no number, so that means it's a 2, so my index is a 2. And now I can break this down. 12 goes into what? 2 and 6, and here I have 2 and 3, right? And I'm only going to look at the ends of the branches, so all the prime factors. So if a number breaks down as far as it could possibly go, here we are at 2, 2, and 3. So I'm going to take, I've identified the index, I factor completely. Now, I need to group them in index-sized groups. Well, my index is 2. So I only want the same number, whatever number that might be, in groups of 2. So I have a 2 here. Right? Does 2 have another friend? Well, sure, I have another 2 here. So I have 2 2s and a 3. Well, I'm going to take this group of 2s and circle them, and then I'm going to put a box around the 3. All right? Then that helps me determine what's on the outside and what's going to go on the inside. Now, whenever I circle a group, it can only come out one time. So these 2 2s are going to come out one time. So I have a 2 out front, so that's on the outside, and a 3 left underneath, and that's on the inside. All right, so the square root of 12 is really 2 square roots of 3. Now this is a really simple example because there are only 3 prime factors. Now let's take a look at something that might be a little bit more disgusting here. Let's go with, ooh, I like this one. Another example, so this is example 1. Let's take a look at another example here. Let's take a look at the square root of 54. Again, my index is a 2. And so now I want to factor. So 54 is what? What time? Well, I know 54, it's even, so I could at least divide it by 2, right? So let's do that. So I have 2, and I get on my calculator, figure out 2 and what? 27. Well, 27 I know breaks down into 9 and 3, and 9 breaks down into 3 and 3. Okay? Well, now my index again is 2, so I need pairs, right? So index size groups. So I need at least, or I can only have groups of 2. So I'm looking at this 2. Is there another 2 along the outside? No, so I cannot match him up with anything. So I put him in a box. Here's a 3. Is there another 3 that goes with it? Sure, there's another one here. So I have 2 3s here. And here's another 3. Well, this 3 doesn't have a friend to go with it. Right? He has to have another friend to go with it. So I have a group, 2 3s here, 1 3 by himself, and a 2 by himself. Now, what's going to come outside? This group of 3 here, these 3s are going to come out one time. So that 3 is going to come out front. And that 2 is going to stay underneath. And when I factor, I'm really undoing multiplication. So when I put it back in, I have to multiply them back out. So the 2 stays underneath, and that 3 is going to stay underneath. So 3 is out front, and 2 times 3 we all know to be 6. So 3 is roots of 6. The square root of 54 turns out to be 3 roots of 6. Not bad. Now, let's change it up a little bit. And let's say that my index is a 3. So let's try this. Let's go with the cube root of 432. I know that's a big number and it's disgusting. But if we take our time, I promise you we'll be able to get this thing sorted out. All right, so it ends in a 2, so I know that it's even. So I can break this into 2 times 216. Again, I could do 2 times 108. I could keep going in 2s. I could say this is 2 and 54. Hey, I've seen that before. So that's 2 and 27. I have a 9 and a 3. A 3 and a 3. All right. Now, my index is a 3. Oh, excuse me. My index is a 3. So here I need to put these, I need to collect factors, the same factor, I need to collect in groups of 3. So here's a 2. I need 2 other 2s to go with it. So 1, 2, 3. So here I have 3 2s. All right, here's a 2, but I don't have any other 2s to go with him. So I put him in a box. 3, there's in 1, 2, there's 3 3s, so I could group those together. And that's it. So now what's going to come out front? I have a 2. This 2 is going to come out front. I have a 3 that comes out front. Again, we're multiplying. And what's left underneath is a 2. And 2 times 3 we know to be 6. So I'd have 6 square roots of 2. No. That's an index is a 3. So I'd have 6 cube roots of 2. I apologize. All right, what about variables? What about variables? So we're going to have to handle this whenever we have variables. So the question is, what about variables? Let's take a look. Let's say we're looking at the cube root of x to the 5th power. Well, let's go through the process again. My index, what's the index? The index is 3. And the prime factorization of x to the fifth, that really means x times x times x times x times x, right? X to the fifth power is x times x times x times x. Well, I need to get groups of how many? I need to do groups of 3. Well, here's 1, 2, 3 x's here, and I have 2 x's left out. So now these 3 x's come out as one single x. And let me get my radical symbol together here. It's the cube root. And now how many x's do I have left over? I have 2 of them. So x times x gives me x squared. And he stays underneath. All right, time for one more example. Let's combine these two. So the final example here. Let's take a look at the cube root of 32x to the 7th. All right, so let's break down that 32. The 32 is going to give us, let's see, 8 and 4. 8 is 4 and 2. 4 is 2 and 2. And that 4 is 2 and 2. My index, I was supposed to do that first. The index is at 3, so I need groups of 3. I broke it all the way down. I went groups of 3. Ooh, I need to get my x to the 7th. X times x times x, 3, 4, 5, 6, 7. Okay. All right, so I keep my numbers. I do the tree. My variables, I just line them out. So groups of 3. So 2, 2, 2. There's 3 2s. And I only have 2 left over, so I got to put these guys, put those in a box. And then I have, let's see, 3 x's here, and 3 x's here, and 1 left over there. So let's determine what's going to come out front. This group of 3 2s is going to come out as 1 2 out front. That group of x's is going to come out as 1 x out front. That one's going to come out as an x out front. And then underneath, we have a 2, and an x. So let me clean this up a little bit. 2 times x is 2x squared. And I'm left with the cube root of 2 times 2, which is 4x. So that is as far as I can simplify. Now, we didn't necessarily find roots, but I'm going to show you method 2 in another video.